Welcome to Chapter 9. So, in this chapter, we discuss music and the brain. The first slide that I give you, I hope that you'll click on it and watch Bobby McFerrin. You've seen him through our documentary, but this video really shows how human beings are musical creatures and that we are predisposed to being musical. It's really interesting because this audience that he's speaking to is scientists. And I'm sure some of them do have some musical ability or musical background, but the majority of them do not. And it's really interesting to see how Bobby can get a whole audience to be musical and to do a musical activity. So I do hope you enjoy that. So, due to rapid advancement of technology, we're able to see what's inside our brain and to see the tiny details of our brain. Now, there are two neuroscientists that do research in this area. Now, there's numerous, but these are the two big names. One is Oliver Sacks, and the other is Daniel Levitin. Both have written books. Oliver Sacks wrote Musicophilia, and Daniel Levitin wrote This Is Your Brain on Music. Both of them are New York best-selling books, and they're easy to read, they're easy to understand, they're meant for the non-musician or musician person to read, and great books if that's an interest of your area that you might want to look at possibly after the class. But thinking about technology, we have EEG machines, we have MRIs. Those machines let us look into the details of the brain and to see what's happening under different circumstances. So think about what amazes you the most about human brain. Just looking at it, the structure, and even the capability of storing so much information. That amazes me. All right. So when we talk about the brain itself, first of all, realize the brain is complex. Now, again, this is not a neuroscience class that deals with the complexity of the brain, but just overview of it, it's about 3 pounds. Those are 3 pounds you'll never lose. And it's over 100 billion neurons or brain cells. That's a lot. That is a lot. Now, part of the human central nervous system, and this includes the brainstem, the spinal cord, the peripheral nerves, and the nervous system, along with the brain itself. And in a second, we'll look at the different lobes that it's divided up into. So, the brain, its structure, it's surrounded by a cerebral cortex. And the cerebral cortex is a layer of gray matter that covers the outer surface of the brain. Now, looking at the brain itself, it's wrinkled in appearance. It's bilaterally symmetrical, means that it's dividedly even. Each half is symmetrical, even. And there's a right and left hemisphere, and it's divided into 4 lobes. And we'll talk about the lobes on the next slide. So, the lobes, you have the occipital lobe, the parietal lobe, the temporal lobe, and the frontal lobe. So the occipital lobe deals with vision, and that's located in the very back of the brain. The parietal lobe is located it's on the top back part of the brain, and it's dealing with sensory processing. Now, the temporal lobe located at the bottom part of the brain, bottom midsection to the back. Um, it's dealing with your auditory perception. It does your language, and it does your visual processing. Now, notice that temporal with the visual processing is dealing with the process or the processing of your vision. Just remind yourself that occipital lobe is dealing with vision, and then it processes through the temporal lobe. All right, so sorry, I'll continue on. Frontal lobe, dealing with long-term planning, movement control, and speech production. The frontal lobe is in the front of the brain, and notice or know that that's where our speech is produced, or where the speech processing is done. And within each lobe are sensory, motor, and association zones. And we'll notice that when we start getting into it, that music affects all these areas, not just one. So, what is plasticity? Plasticity is the brain can change itself, or the brain's ability to change itself. Now, when we refer to the term neuroplasticity, the brain structure can be modified under certain conditions. Now, when we talk about neuroplasticity, that usually means if it's a result of an injury or through learning experiences. Think about if you were to compare a brain of a very young infant to maybe someone in their 50s. The brain structure, the neuroplasticity, is going to be completely different. More than likely, a 50-year-old would know more than, an infant or a toddler. And so their brain structure is going to look differently. And so it's interesting to know that over time, that our brain changes its appearance as far as maybe wrinkled in structure. And the neurons, the 100 billion neurons, there's always a saying, neurons that wire together, fire together. Neurons that fire apart, wire apart. So notice that when you are making learning experiences, your neurons are connecting and they're firing together. The more that you do of something, the more neurons that are going to be clustered or more developed in maybe one of the areas. So learning experiences cause the brain to rewire itself into a neural network. So if you're trying to, a musician's brain is going to be different from an athlete's, or maybe someone who is an avid reader, or, there's numerous brains. From a distance, they may all look very similar. But if you were start to look at the structure, you'll notice that some areas might be more well developed than others, depending on the person's activities. Plasticity, when we're referring to the brain's ability to change itself, is the central focus of experiences. Now, again, I said earlier, the brains of adult musicians are different than non-musicians. Again, for someone who plays sports, is going to be different from someone who is a non-sports person or a non-athlete. So, pruning. This is the ability of the brain to basically say if you use it or you lose it. When we talk about using it or losing it, it's important to realize that the first years of life, more synapses are produced than are necessary. Synapses means there's more pathways than there are really necessary for someone to survive. Pathways for someone to have ability to learn. And the purpose of that is for babies who are learning, they need that. And it's good for parents to understand that when they're really young, when they're infants, that is crucial for development. Because think about it, an infant, a baby, a toddler, they're all learning a language, right? They're learning what their parents say, they're learning what they hear. All these auditory processes are developing. And so that's why the brain is has so many more um, synapses that are needed. And basically, the purpose of it is for adapting to the environment. Now, this is really interesting to know that language is unknown at birth, so the brain is equipped to learn all languages. That's why you see a lot of parents nowadays. They teach their children to be bilingual, maybe English and Spanish, or maybe if the parent is from another country, they'll teach them that language. Now, it's really interesting to know that most of the studies conclude that by the age 7 or 8, students or children who are grown up in a bilanguage environment kind of struggle a little bit with both languages. However, past age 7 and 8, they blossom. They progress way faster than their classmates. So really interesting to know that we're not born to actually speak the English language. We're actually born with a blank slate. And yes, you recognize your parents' voice and all that, but know that language is unknown at birth. So, all people inherit a brain predisposed to be musical. Dr. Stanley, she just retired from Florida State University, did a study. Did a study on African newborn babies. Now, in Africa, the babies that she studied were premature. They were from different tribes. Now, what she created was the PAL, PAL, the Pacifier Activated Lullaby. And during this study, premature babies are, sometimes they have the inability to suck and to suck on a pacifier, or to suck to receive the nutrients that they need from the mother or from feeding. And this type of device helped them with sucking, which is needed for survival. The baby needs that in order to survive with food. Now, what she did was the baby would learn to suck to the rhythm of the tribe's music. She recorded it, and because that's what the baby would hear in the womb, that tribal music from that tribe was being played while the baby was in the womb. And so she would play that, and the baby would actually begin to suck on the pacifier. Now, what is very interesting to note is when she played a different type of music from a different tribe, the baby actually stopped sucking. And so, which is really interesting to know, that we are predisposed to be musical, but the environment of even when we're in the womb is affected. And so it's just an interesting fact that, the PAL is great in order for babies to survive. They use in the U.S. and I'm sure other places, they use to play lullabies, because lullabies are something that is just kind of in our natural DNA, that and babies will suck to the lullaby. And when the lullaby is stopped playing, the baby will actually stop sucking. It's kind of a behavioral type of approach if you're thinking about it from a psychological point. So it's just an interesting kind of study and study of research area. So this clip is Oliver Sacks speaking about his book about special cases of musical behavior. He also looks at the behaviors of prodigies with amusia, Williams syndrome, Alzheimer's disease, and this video talks about, excuse me, talks about a man who was struck by lightning, who did not have much of a musical ability, but after a while he actually became a pianist, and began to write his own music. And this was after he was struck by lightning. And there are numerous cases of this happening. And so he talks about it in his book, Musicophilia, which is just a really interesting thing to look at. Oliver Sacks is, you'll really enjoy his voice. It's very, very calming, very low-key. But I do hope that you'll enjoy it. Now, when we get to musical savants and prodigies, they both possess highly advanced skills. However, here's the difference. Savants usually are advanced in one or two areas and are limited cognitively. You know, there's a difference between a prodigy of, I'm trying to think of a savant will likely be blind or basically be on the autistic spectrum. A prodigy, you could probably think of like Mozart or Beethoven. Probably Mozart was probably the one because he was so young, and when he was writing his music, and he didn't live very long. But to know that he wrote so much music in his little lifetime, and it's interesting to think, what if Mozart would have lived to be, I think he died around his 40s, but, you know, or maybe even earlier, but just think if he lived to be 60 or 70, what music would he have written? But realize that savants are usually advanced in one or two areas and limited cognitively. There is numerous cases of savants where there's one in England who he is a great pianist and he's blind, but he cannot tell you how many fingers that you're holding up. He cannot tell you simple math equations, how to answer that. But in music, he's able to play different styles on the piano. And it's you know, fascinating to see the brain structure and the complexity of the brain for the different types of people. So what is amusia? So think of aphasia. If you've ever heard that word, aphasia means it's a loss of language. So in kind of the reciprocal part of that, amusia is loss of musical skills due to brain damage. And in the documentary, you'll meet, if you haven't already, there'll be a woman who has amusia due to a brain damage. And you'll see her in her sessions and what happens. Anyway, when we're talking about amusia, it may be global or specific in the brain. You may be able to perceive or understand music, however, you may not be able to sing a tune or follow the pitch or be able to play the rhythm. And you may be able to have done that before. Expressive amusia is the lost ability to express oneself musically. Again, this may happen after brain damage. I don't think people are born with this. There may be some cases out there, but again, it's mostly due to a type of brain damage. Williams syndrome, a genetic defect that leaves the individual cognitively impaired. Average IQ is about 55, and they have peaks in different cognitive domains. They may have strong abilities in language and music, but poor spatial and mathematics skills. I did have on this slide from previous semesters a YouTube link to a Law and Order SVU video of someone with Williams syndrome. And just by the way, I love Law and Order SVU. But in any case, the someone who had witnessed a crime, she was able to pick out the tone of their voice. She had perfect pitch, and she was able to replicate the person who committed the crime just by their voice, because she was in a different room. Now, the person with Williams syndrome, they're very affectionate. You know, they might come up and hug you if they find you to be a nice person. They don't, but their average IQ again is 55, and so talking about it, they may be strong at musical skills, they may be strong at language skills, but sometimes they may have the spatial and mathematical skills that that are poorly. So I believe the Law and Order SVU episode, they labeled it Prodigy. No, I'm sorry, they labeled it Savants. And, I'm not really sure that should have been the correct label for it. But they do talk about the girl with the Williams syndrome. And I think it is portrayed very well to understand people with Williams syndrome and where they're coming from. Alzheimer's, again, this is something that is constantly being researched. Now, with patients with Alzheimer's, previously learned musical skills are often present even during severe cognitive impairments. So a lot of times, a person who has Alzheimer's, it's may not remember the name of their children or the name of their husband or maybe where they grew up, but maybe they're still able to play the piano, or maybe they're able to sing a hymn that they really loved. And this is fascinating to scientists. Why is someone someone with Alzheimer's disease, why are they forgetting some information, but in some instances, why are they remembering music? A good example would be the movie The Notebook, where the elderly lady who has Alzheimer's, she doesn't remember much about her previous life, but she does remember how to play the piano. And, but at the beginning before she plays the piano, she's like, I don't know how to play this. But then she touches the piano and something happens to where it brings back to her. This video, I hope you'll watch it. It's very touching and it's very personal. And to know that this man who could play the piano from memory, even though he could not identify the composer or title. It's just an interesting aspect. Now, this video, I believe it's with an elderly lady who she is not able to remember certain family members, but she's able to go back and able to see. She remembers certain hymns from her childhood. So, imaging techniques for studying the brain. This is actually, you may have seen this, I see it all over the time on Facebook, about how music affects the brain and the technology that is used in order to look at the brain and the electrical signals that are going off while people are performing or even just listening to music. So you have the EEG, which is monitoring the ever-changing electrical activity of the brain. You've had an MRI, which is you're placed in a large magnet. It looks at the structures with precise detail. So some researchers may look at an MRI maybe before, during, and after some type of musical activity. A PET identifies the metabolic activity or brain flow in a living brain, which is kind of cool. And you'll see that also on the documentary of some examples. And then an fMRI. Basically, it combines the MRI and the PET that provides information for both structure and function. So, when we're looking at music and the brain itself, music processing involves motor skills, cognitive skills, affective skills, and memory components of the brain. We know now that the brain just doesn't affect one area, it affects the entire brain. Now, it's important for us to realize that still the research in this area is fairly young, within the past 20 or 30 years. But it's such a hot topic now. And it's important to realize that music does affect us cognitively and emotionally. And it helps us through, maybe through someone who has like a brain damage, and helps us get back on our feet. And we'll talk about that more when we talk about music and health. However, more research is still needed in Western and non-Western musical experiences. This will talk about, even if music is a universal language, if it is or if it's not, but does music still affect people the same way that it does in Western cultures versus non-Western cultures? All right, that is the end of Chapter 9.